Hey class, it's me, your professor. I'm down here in the corner, back from Thailand, back in Okinawa. Um, yeah, I'm still kind of on vacation here. So, week 9. A few things. Why I have this screencast going up is that I was looking over the learning objectives and content for this week, and a couple things caught me off guard. Primarily, when I saw they were going over the ANOVA, I got all excited because it's a fairly straightforward, easy analysis to do, when to use it, and how to interpret it. But then I was looking at the learning objectives here and talking about particularly learning objectives 2 and 3. We're just going to ignore those, okay? And here's why. A, you don't need to know them for this class. That's my opinion, has always been my opinion. I don't know where these came from. 2, I looked at the last quote-unquote quiz 11 or online assignment at the questions, and there's only one, and it's very, very simple. And then 2, I went and looked at the final exam, and there's only 3 questions, and again, they're straightforward single factor analyses. So yeah, I don't see the need for you to learn something that's a little more complicated than what you need to know, and then aren't assessed on it. So in all fairness and transparency, I put a strike through here on learning objectives 2 and 3. And the only information, I went through all the links here and the lecture notes, and it's buried down deep in the lecture notes when it talks about 2 factors, which is an ANOVA model, or two-way ANOVA. You can just bypass that. So the ANOVA, analysis of variance, really what it is analysis of means. We know that the variance is the square root. If you take the square root, that's a standard deviation, but even that's irrelevant. What ANOVA really has to do with comparing two or more. You can have 3 or 4 groups. So whether it's males or females, you've got teams, you've got production facilities, you've got types of teaching strategies. If there's 2 or more methods that have a dependent variable, okay, a single dependent variable, that's when you would use the ANOVA. And the reason why is that you wouldn't do like 3 separate t-tests, because we get into things like error rates and that sort of thing. Really, you're looking at 1 independent variable, 1 dependent variable, but that 1 independent variable has 2 or more levels. Okay, in this case, they're groups. So, for example, we have this example here. I'll just bring it out here. I'm going to bring up another one, actually. I'm not sure where it is. This one is, which you'll see in a later assignment. It's these types of yarn that are used. Key thing you need to know about ANOVA analysis is your groups need to be in separate columns up here. And when you run ANOVA, it's very simple. You just go to Data Analysis Tool Pack, ANOVA Single Factor, click OK. You select your data here. Your labels are in the first row. Make sure you specify your alpha. It's very important, whether it's 0.05 or 0.01, whatever the question's asking, or if this is real world, what your decision level is. And then your output range and where you want to put it, and you just click OK, and you'll get an output that looks like this. So the key thing with the ANOVA, you're going to be looking at 2 things. You're always going to get your group summary here, and here's where you see the variances and means here, the averages for the differences. But what you want to look at is the calculated F value and the critical table value that's looked up for you. If this number is less than this number, you have an insignificant or non-significant result, and what you're going to see here in your p-value. So just know that those 2 things, the output is what you're going to be looking at. Again, so in this example, this p-value is 0.36. It's greater than 0.05, which I had specified earlier. So we know it's a non-significant. So these things, you can assume that these averages, although they're not equal, they're not very different either. So, and that's your null hypothesis, is there's no difference. The things are the same. The alternative hypothesis is one or more of the groups would be different, or in this case, you want to specify a direction for a particular group. You could do that as well. We'll get to when you want to know if this ever gets to be significant. There's this thing called the Tukey's Honest HSD test. I forget what the S stands for. And what that does is it tests the differences between these means. It compares, so if there's this case, there's 4 levels. It compares 1 to 2, 1 to 3, 1, 4, 2 to 3, 2 to 4, 3, and then 3 and 4, and then you look for the significant differences between those groups. But we don't need to be concerned with that just right now. So the ANOVA, let's just keep it simple. Pay attention to the fact that we're just using single factors. It's one independent variable with 2 or more levels or groups, a single dependent variable. And this whole process of the hypothesis testing really is specifying your null, specifying your alternative hypothesis, running analysis, looking at the p-value and the differences between the calculated and critical values of f, and then making your interpretation of those results in relation to those hypotheses. So to accept the null or to reject the null. And that's it as far as the ANOVA is concerned. So not too bad. We also have a discussion activity that's kind of related. Now there's I left the 2 in there because honestly those 2 are activities. I've seen them in the past and I kind of like them. The types of error, type 1 and type 2 error, are important for you to know. Basically, type 1 error is a false positive, type 2 error is a false negative, because it happens all the time in the real world, in actual research studies, and the like. So there's just the activity I should just come up with some examples. So, but the other one, the Six Sigma, I left that in there because it's actually a real life application. Me personally, I am a Lean Six Sigma yellow belt, green belt, and black belt. If you don't know what that is, I suggest you Google it because it has to do with quality control and that sort of thing. Just my little hint. Hindsight's 2020. I didn't know about the whole quality field and Lean Six and total quality management field. If I had known this like during undergrad, I probably just would have finished undergrad and went and got a black belt, which is like a 3 to 6 month program. If I knew management consultancy was going to be my forte or gig, because you make a lot of money. And when you are a black belt or master black belt, you make a lot of money. Companies pay a lot of money for you to come in and to determine where your deficiencies are in your service and production of whatever you make. So just know where that field comes from. And if you want to do a little more research, just Google Lean Six Sigma. The ASQ, American Society for Quality, is like the preeminent association associated with that. If you ever even go down that track, I can give you some more information about it. So, okay, so that's it. Week 9, simple single factor ANOVA. It's all you need to concentrate on. You don't need to get caught up in the single factor and blocking a second factor and the effects of 2 factors. So there you have it. If you have any questions, just ask. I haven't graded this last assignment. I'm assuming you all did very well because I didn't get any questions really. I think I got 1, but that's about it. So I think the video walked hand in hand on what you need to do and know. So that is it. And then we're winding down here because after this we have that last quiz assignment and then the final. And listen, here's the deal with the paper, the critical article review, the assignment that I love so much, because that's next week. Here's my offer. You can choose not to do it. Don't do it. Don't do it. I will give you an 82 straight across the board. So I will, at the end of the week, I'll look at the assignment folders and everyone's who didn't submit an assignment, I will just give you an 82. If you want to do the assignment and earn something greater or run the risk of earning less than an 82, have at it. That's your choice. But just so you know, if you remember way back in the beginning of the semester, we did a little grade calculator, and we have these weights for the various assignments, an activity in the class, they're really kind of minimal if you really do the math. So that's just a hint there. So if you plug in an 82 for where you are and where you want to be, I'm sure you're going to be okay. But just throwing it out there, you choose not to do the assignment. People will email me, "Are you sure I don't have to do anything and I get an 82? Yes. Don't do anything, get an 82. Do the assignment. You can either do better than 82 or you can consequently do worse. So it's your call. Okay, so that's it. Let's have a great week, and any questions, just ask.